Hello friends, I am back, and yes, this is an experiment that you cannot do at home, so it's not homemade, but besides that, let's get going. So right here, and yes, this is a catapult. We're back to catapults again. But we're not talking about elasticity today. We're going to talk about energy. So let's first talk about energy first. So what's energy actually? The ability to do work, right? And we need to know two most important energy types. Potential and kinetic. So, what we have here is a catapult, right? With the lever here. Mostly we're going to think about this, not the others. Alright? So, whenever we pull this down, here, let me get a ball as an example. It'll be a good example. Alright? So whenever we pull a ball, when we have a ball right here, and pull the lever down. Oh, that's bad. Alright. I think that's better. Alright, good. So whenever we pull the ball down, potential energy is created. Because here is the potential energy. Then it'll convert to kinetic energy when the catapult moves. So the kinetic energy, when the catapult moves, it'll come to the mass, which means the ball, and then that mass will have the kinetic energy to move. So we're going to do another demonstration. So here, we do it again. So here, instead of here, hold on. First of all, if we have the here, that means it'll have less potential energy than this, right? So we will say that the more you pull it down, more potential energy it has. The less you pull it down, the less potential energy it has. Which means, so we know that potential energy is proportional to kinetic energy. So less potential energy means less kinetic energy. More potential energy means more kinetic energy. So that's why it doesn't do that much. It does give work, but it doesn't do that much energy. It doesn't give that much energy, I would say. So here. Alright, see? It's not very exciting, I would say. But if we do this, we know the two basics of energy that I told you about. But is there any other types of energy that we're seeing? Well, there are two actually. Those will be converted from the potential energy to kinetic energy, and kinetic energy will convert it to the other energies that we're seeing. So when we pull this down, potential energy is converted, and then it converts to kinetic energy. And then when it comes to kinetic energy, it creates sound. Sound is also energy, and it's a type of kinetic energy. The movement of sound waves. That's kinetic energy, a type of kinetic energy, I would say. That's why it's a sound. That's why we call it sound energy. And then the last one, thermal energy. Where do you see thermal energy? As you know, thermal means heat, right? But where do you see heat? Well, we know friction, right? Friction creates heat. So, where is the friction coming from? The ropes. These elastic ropes. When this is pulled down, it comes back. See? It creates a little friction. Even if it creates a little friction, it still creates heat. That's thermal energy. So, I'm not seeing anything else right here. So this is a very good demonstration of energy conversion. So yeah, my work is done, and I hope you enjoy my experiment. See ya.